Good morning, everyone. Lovely to have you all here doing some lovely geometry fun today. Just before we start, just wanted to remind you to follow on the Eventbrite the hashtag London Maths. If you follow that for any future events that we put on, you will get a notification for that. So that's all I needed to tell you. So we have the lovely Clarissa joining us, and I'm going to let Clarissa introduce herself. She kept me sane during the first lockdown, so helping us and all the other Twitteratis doing all this fun stuff with geometry and maths. So there you are. I'll give you Clarissa.
Thank you, Jeffleen. I think I kept myself sane during lockdown as well with all of that. So welcome everyone. As Jeffleen said, I'm Clarissa Grandi, and by day I'm a maths teacher. I teach maths in a lovely sixth form in Suffolk, but I've also dabbled on the side in a little bit of geometric art, but that's a more recent development. For a while now, for about, oh, I've got some in the meeting room, hold on, sorry. For about, I think about 4 or 5 years now, I've been really keen on using mathematical art in the classroom. I've only been doing my own the last couple of years. And so I'm going to start today's session. Today's session, we are going to do some hands-on drawing with our compasses. And it's going to have a bit of a Christmas theme, but I'm going to talk you through sort of 3 different patterns. And the last one will be the Christmassy one. And I'll talk through how they can be used in the classroom and why it's quite important to do this sort of thing with your students. But before I do that, before we get going, you can kick back and relax for a bit, because I'm going to show you my presentation, which is it's my spiel basically about why it's really important, in my opinion, to do these types of activities in the classroom. So when I talk about mathematical art, I'll first start by explaining what I mean by mathematical art, and so you can start to see why it could be a powerful tool to use in the classroom. So I'm going to share my screen, and we'll share this one. Hopefully this should be large when I share it, but if not, you'll have to find it and pin it, I think. I'm never 100% sure what you see. So let's have a go. You can actually, oh no, because I lose the chat when I share my screen. Okay, so hopefully you can all see that nice and large. Give me a thumbs up if you can. I can see a few of you. Brilliant. Okay. Okay, so we're doing some Christmas geometry today. If you do want to see my own art, you can follow me on Instagram. I've been a bit quiet the last few months, what with everything else, let's face it. But Clarissa Grandi Art is where you'll find my own stuff. I'm complex number on Twitter, and that's with a 0, not an O. And my website's artfulmaths.com, and I'll just be showing you a little bit about that during the course of the presentation. So first of all, starting with, and there we are. Oh yes, equipment for the day. We'll just run through that. A few sheets of paper, maybe 3 or 4, pencil, ruler, pair of compasses, and you will, for the Christmassy bit, just admitting people, for the Christmassy bit at the end, you'll require a small piece of tracing paper, and then you can have coloured pencils or pens or whatever's handy if you want to embellish your work. So starting then, what do I mean when I talk about mathematical art and using it in the classroom? So I've put together 6 images, which for me exemplify quite clearly why the images could be considered maths and at the same time art. So I'll show you those now, and then I'll talk through, you know, the things that you'll have your own ideas, and I'll talk through the things that that make me feel that it's mathematical. So this is the first one. This is by Escher, more famous, of course, for his impossible buildings. But this is a watercolour by Escher, where he was exploring hyperbolic tessellation and tiling. This is by an artist who uses Excel spreadsheets to create this artwork. I will have to keep admitting people. Who creates this artwork from trigonometric functions in Excel, and his name is Hamid Nadere Yagane, and you can find him on Twitter. I'll pop names up in the chat in a bit. This looks like it's a 3D object. It almost looks like it's been sort of laser cut into wood, for example, this fantastic fractal. But actually the whole image is computer generated. And this is by an artist called Tom Bedard. This is actually 3D. This is laser cut wood. And this is by George W. Hart. You'll all be aware of Vi Hart. This is Vi Hart's dad. And he's got a fantastic website, which I'll show you the link to a bit later on in the presentation. And yes, and he does a lot of things that you could collaborate with the DT department for. He uses a lot of laser cutting and tools like that to create his 3D sculptures. This is 3D printed, so this is in plastic, and this is by an artist called Bathsheba Grossman. And this last one then, and this is the artist I would recommend you introduce to your students, because this artist is called Regolo Bizzi, and he's Italian, and well, that's not the reason why you should introduce him to your students. He does all his mathematical art using the equipment that your average 14-year-old will have in their pencil case. So he uses felt tip pens, coloured pencils, rulers, compasses, and that's it really. So his art's really accessible. Students can look at it and think, oh, I could have a go at doing that. And so he's quite a powerful artist to introduce to them. So there's our 6 images, and they're quite clearly art. They're beautiful, they're colourful, elegant, but they are also, I'm sure you can all see, they are also mathematical. So sorts of things that make them mathematical then. There is a sense of regularity about them. They are quite clearly generated by the following of rules or step-by-step algorithms. There is quite clearly repeated pattern, sequence, and there's quite clearly both rotational and reflective symmetry. There's tessellation, and the art can be described as geometric. There are also, if you dig a bit deeper into the mathematics behind the art, there are also ideas of ratio and proportion. Just admit someone else. Ratio and proportion and relationships between lengths or numbers and so on. And that ties very much into art, because behind those ideas, the ideas of proportion and ratio, are concepts such as harmony and elegance. And we often talk about harmony and elegance and beauty in mathematics, and we talk about the same principles in art. And I often feel that mathematical art is where the two overlap. And I think a lot of people think that mathematics and art are opposite ends of a spectrum, but it's as if the spectrum then bends around on itself and they overlap in this sort of space. I think it's also mathematical in terms of the tools they use, the artists use. And the wonderful thing is these are tools that we can find in Maths Classroom, and perhaps you can borrow them from DT as well. So ruler and compass, quite clearly. Tracing paper, we'll be using that today, and your students need to know how to use tracing paper and how to use ruler and compass. Grids, a lot of mathematical artwork is done on a grid, be it a Cartesian grid or a grid of squares or an isometric grid. Graphing software and coding, GeoGebra, a lot of beautiful art being done on GeoGebra on Twitter at the moment. And these are all things that your students can access. And then some art was done with 3D printer or with a laser cutter. And you'd have to outsource that, but that might make some nice cross-curricular work. Just letting a few more people in. So these sorts of patterns, they're rich in mathematics, and but it's not just the number that lies behind it. It's actually, I think it's very important, the making of the patterns, and a different kind of thinking occurs when children make these patterns. It's a sort of mathematical thinking without number, but it's still very much mathematical. So I'm going to just show you some of my students' work. So this and the resources for your students to do these lessons are all free on my website. So this is Curves of Pursuit. I think it's my all-time favourite. You can see lots of lovely explorations. Students always take it further than you think they will, and students always surprise you. This is Celtic knotwork, and there's a full step-by-step presentation on the website. This is quite challenging. It requires a lot of attention to detail, counting, and focus. Impossible objects, a nice link to Escher's work here, and ruler and compass constructions. All of these are constructed with the ruler and compass constructions that your students need to know. Mazes and labyrinths. So labyrinths provide lots of compass practice, as you can see. Mazes are really good for forward planning and for problem solving, and for sort of perseverance. Yeah, so that's a lovely lesson. This is my epicycloids lesson. So constructing cardioids, epicycloids, nephroids, and there are links to factors and multiples, and there's also a lovely introduction that involves students visualizing a circle rolling around the outside of another circle, and trying to visualize the path of a single point on the circumference of the outer circle as it travels around the inner circle, and what would happen if you made the inner circle larger or smaller, and so on. So lots of opportunities for visualization and for thinking about factors and multiples hidden in these lovely patterns. Good Valentine's Day activity as well, because one way up they look like bums, I'm afraid, but the other way up they look like hearts. But they are somewhat. One child will always come out with the bottoms comment. And what have we got here? This is a fantastic activity, originally done by Liz Meenan. She's written a book. I can't remember the name of it. It'll come to me and I'll let you know. But she kindly allowed me to share the resource on my website in a PowerPoint presentation. And this is folding polygons from A-sized paper. So the starting unit is either A4, A5, A6, and so on. And students are shown how to construct their different polygons just on plain white paper. And then their challenge is to create a design using different sizes of paper and different shapes if they like, or they can do them all from the same shape. So loads of great mathematical thinking going on. And lots of appreciation of how things tessellate and how shapes fit together, and so on. And wonderful for classroom display as well. You get some corking pictures out of this lesson. And this is Islamic geometry. I've done a presentation for fourfold patterns, and again these are constructed with ruler and compass, and I think it's perhaps one of the first times your students might realise the importance of the perpendicular bisector. It's really handy for constructing right angles, and I think sometimes that's lost. It just becomes this strange thing that you have to learn in maths and then forget about. And students can work on tessellation, ideas of tessellation, and there's all sorts of angles proofs of congruence, proofs of similarity hiding in these wonderful grids that emerge on their pages. So that's student work. I'll now touch briefly on why you've probably already got some idea of the mathematical concepts and things you can bring out when you're doing activities like this in your classroom, but I'll go a little bit more deeper into why I feel these are important tasks to include in I realise, an already chock full scheme of learning. Key is skill development. Our students don't get enough practice with measuring lines, with using their protractors and their compasses, and year after year, GCSE research on past papers on GCSE outcomes shows that geometry and measures are the most badly answered, essentially badly answered questions on the GCSE paper. They are the most poorly answered, and they are the most often left completely blank. So they're the most often completely unanswered questions. And I think that points to students who are not confident in their geometry. This is students who are not confident picking up that compass in an exam situation, picking up their protractor in an exam situation. And it's simply because they don't ever practice for extended periods of time. We want our children to be confident geometers going into their GCSE exams. And these tasks are one way of enabling them to become more confident. And I think as unconsciously competent adults, we forget how many micro movements there are involved in simply measuring a line, lining your ruler up with the 0 on one end, making sure it doesn't budge when you line up the other end, reading off from the scale. All of these things we do without thinking, but to younger students, there's a whole raft of steps that need to be completed, and they are quite clearly consciously incompetent at that time. And the same with using a protractor and using a pair of compasses. So important in terms of getting students fluent with their tools. Consolidation of key content as well. A lot of these tasks give students opportunities to practice some of these skills in context, and they make sometimes a welcome variation from textbook questions or past paper questions. I'm a big advocate of textbook. I use my textbooks every day in my lessons, but sometimes I think that students can finally see the point of some geometry when they actually get to play a little bit more. Problem solving as well. When students, the lessons begin with a bit of visualization or a thunk or some sort of mathematical question. And then there's a link made to the pattern itself. And then students are shown how to construct or draw the pattern. Someone's just entered, I think, sorry. And then they're let free. So it's up to them then to design their artwork using the skill they just learned, using the basic unit, but taking that further. And there is all sorts of creative problem solving, the kind of mathematical thinking without the numbers. So they might want their design to start at the centre of the page. Well, first of all, they've got to find the centre. So first hurdle to overcome. They might want a series of designs with overlapping circles, and they might want 5 overlapping circles across their page. They've then got to figure out what the radius of what their first circle must be. They might have a design with 6-fold symmetry that they then wish to colour to enhance that symmetry, and they can think about how many colours they could use, or 12-fold symmetry, how many different colours could you use to maintain the symmetry in the pattern. So there is all these sorts of considerations. They're aesthetic, but they are certainly mathematical as well. And the colouring in part of the task is not just busy work. There are all sorts of considerations to do with geometry and repeated pattern and tessellation that your students will be thinking through and working through while they're busy making their patterns beautiful. And last of all, my PowerPoint's not working. Last of all, engagement and enrichment. So in terms of engagement, these sorts of lessons every now and again are fantastic for engaging, let's say, your more reluctant learners, and give you opportunity to praise them. And I think they're really powerful for classroom relationships. I've had challenging lower sets in the past, and for some students, the tasks like these were the first times I was able to praise them for their diligence and their perseverance and how hard they worked in my lesson. And then that has a knock-on effect. So it's the beginning of getting students to associate their maths lessons with positivity, rather than, unfortunately, we know in some cases students have a lot of fear with their maths and they're acting up in maths lessons as a result of that. And so they're great for relationship building. You can make collaborative displays with the work, so the students can work together to make their 9R6 display. So the classroom bonds. And then in terms of enrichment, some of the patterns have rich history, and we're introducing our students to the perpendicular bisector built our civilizations, essentially, and these patterns appear across all cultures. And we're introducing students to a heritage that they won't meet elsewhere in their school curriculum. These are mathematical designs. They're constructed using mathematical methods. And so students are basically, they're left to discover this in their maths lessons. And this is an opportunity to show them the point of a lot of their geometric tools, what they're used for. So there we are, there's my spiel. So hopefully I'm convincing you that there is some point to all this. So whereabout can you sort of slide these activities into your scheme of work? All over the place, really. Of course, in your teaching of geometry and measures, drawing and measuring, the younger students who need to learn to measure lines, 2D, 3D shapes and their nets, compass and ruler constructions, loci, angles laws and angle properties, circle geometry, symmetry and transformations, tessellation, Pythagoras and trigonometry. There are some nice problems you can set with some of the underlying grids. And then in number and algebra, A4 paper is a great source of some third work for older learners. And also in the triangles in underlying grids, you can set problems to do that will have square root solutions, Pythagoras and trig and so on. Sequences for epicycloids and multiple factors and primes. And for solving problems like looking at parabolic curves, for example, students need to form and solve equations, and functions and graphs come into play with lessons like creating parabolas. And then, of course, proof of congruence, and so on and so forth. And then in ratio and proportion, ideas of scale factors and scale diagrams, fraction decimal percentage conversions can be done with sort of modern art maths grids, and similar ideas of similarity and congruence. So the curriculum is rich for places you can slot in this sort of activity. So how do you go about doing this? We're not art teachers, we're maths teachers. So I'm going to be talking through a design with you today and showing you how I would draw the mathematics out of it and how I would teach it to students in my classroom. But there are other sources of really great ready-made resources. So first of all, there's my website, and I think I've snapshot the laser pointer on. Oh, that's someone else's laser pointer. I think this is a little video slide from me talking about it previously that I've cut and pasted from a previous presentation. Ignore the laser pointer, I'm not controlling that, feels a little odd. Yeah, so there's a resources section, and that's where you'll find the mathematical art lessons. There's also ideas for running origami, either in maths lessons or running an origami club. There's a list of Apple iPhone puzzle games that have a mathematical art theme. There's a blog that I update every now and again, really good for finding seasonal activities, because I tend to sort of do it around about Christmas or Easter when I get another idea about something you could do then. And then you can contact me there as well. So there's that, and everything on that website is free. And then there are these 4 other websites that are really good. So mathscraftnz.org is a website full of really nicely presented, ready to go mathematical craft and mathematical art activities to either use personally or to use in the classroom. And then mathmunch.org, that's still going. They have, but they used to write a maths art newsletter, which has since come to an end, but the archive is there. So if you trawl through the archive of their maths art newsletter, there's lots of lovely ideas. Making Math Visible is George Hart's website, and loads of projects there. Some of them quite in depth, and some of them would require, the help of the DT equipment and stuff like that. And other stuff is less intense, if you like, but it's really rich. and lots of his lovely sculptures on there as well. And then last of all, you may well have heard of mathagon.com. It's a more recent website. I think it's been going about 3 years now. And I can't remember the name of the chap who's created it, but it's a visual feast. And he describes it as an online textbook, but it's so much more than that. I don't think that sells it at all. So there's ideas for origami, there's lots of visualizations, you can do tessellations, interactivities and things like that. So that's a really nice one to explore as well. Okay, where have we got to now? Oh, yes, and there are the 2 books I've written as well. I've got to do a quick plug. So I've put together an Artful Maths teacher book. I've taken my 4 of my favourite lessons from the website, and I've created 2 more that are only available in the book. And I've put together step-by-step guide to how to teach the lessons, and the presentations have all been remastered and zhuzhed up a bit. And so you get, with the teacher book, you get a complete set of downloads, all the templates you might need and the presentations, and then a set of instructions, suggested guidelines, which include questions you can ask, prompts you can give, where the mathematics is, ideas for extension, and ideas for support. And then there's also an activity book, which is designed to be standalone. So you could use it alongside the teacher book if you were doing a mathematical art week for year 6, for example. Every student could have their own activity book, and it then ties in with the teacher book. But I wanted it to be something that interested teenagers or adults or children could work through on their own at home. So all the instructions are also in the book. Not so much in-depth mathematics, but a little bit of the mathematics behind the patterns as well. Students are set little challenges, and then all the templates that they need to create their beautiful patterns are in the book, and there's a set available to download as well, so they can redo them and try different things out and so on. And they're all available from Tarquin Group. Great Christmas present. And now the time has come for us to do some geometry ourselves. So we are going to, we're going to end up constructing a snowflake, but we won't get there yet. I will show you the underlying grid first. So I'm going to stop share. And I am recording this. Sorry, I'm just having a quick look at the chat. I'll do that quickly now. Yes, the recording will be available. Luckily, my Zoom is set to record automatically, so it'll take a while to convert, but I shall share it with Jacqueline, and then she can do with it what she will. And yes, I'm recording. Okay, brilliant. Okay, right. Just going to check my notes, see where we've got to. Okay, so I am going to show you, I'm going to go back to the screen share. I've forgotten I had the demonstration of this. We're going to start by drawing the 7-circle grid. Oh, thanks, Vicky. Glad you're enjoying them. Yes, so I'm going to show you the 7-circle grid. I'd forgotten it was on my PowerPoint, so let me just go back and share screen again. Hopefully it's here. Did I remember to pop it in? We'll find out. Oh yes, here we go. So we're going to be constructing this together, but I'll do it with you. So we're going to start with the horizontal, basically because we need a first intersection, and we would quite like our pattern to be sat nicely on the page. You don't actually need a starting line. We're going to place our compass points at the centre, and we're going to draw our first circle. You'll all recognise this pattern. And then where that circle intersects our line, we're going to place the compass point without opening or closing it, and we're going to draw the same size circle. And where this new circle intersects the original circle, either at the top or the bottom, that position each time becomes the position of our compass point. And you all know we can fit, magically, we can fit exactly 6 circles around the outer circle. And that's quite a nice challenge to set pupils. Why is it that this happens? It's a neat little feature of the circle. why is it that if we use our radiuses, we can chop a circumference into 6? Why is there this beautiful hexagon, regular hexagon, at the centre of our pattern? And so students can think about, they can use geometry, they can use Pythagoras, they could use their angles laws to figure out and to prove that this is indeed a regular hexagon, and so on and so forth. So this is where we're starting, and we'll draw it together, and then I'll show you some ideas that your students can do with it. It's a great pattern in itself just for practicing compasses, compass use at the beginning of a constructions module. And then we'll elaborate it a bit, and I'll show you another activity you can do. We're going to create the double seed of life, and then I'll show you what the more the more adventurous of you, might be all of you, can do with your double seed of life. You can turn it into a torus, and I'll just talk through very quickly how to do that. We haven't got time to do that. And then we'll look at using the 7-circle grid as an underlying grid for students to create a snowflake, and we'll create the snowflake as well. And we use a technique that's used to create what are called biomorphic patterns in Islamic geometry. And we reflect and rotate our tracing paper and transfer our pattern around the grid. So that's the delights that await you. We'll also talk a little bit about how to introduce the snowflakes lesson to students when we get there. So let's stop share now. And now I'm going to switch. If there's any questions at this stage, pop them in the chat. And I'm just going to switch to my overhead video, which we hope is working. Sometimes it crashes. Brilliant. Okay, I'm just going to bring that down a bit. And oops, turn that round. Focus. Okay. I can detect a little bit of lag, but hopefully it's only a little. Hopefully it won't stop you following me. Okay, peeps, we are going to load up our compasses. Now I'm going to use pen, only so that you can see it. You should all be working in pencil. But before we begin, actually, let's put our, if we're thinking in terms of doing our construction in portrait mode, let's pop our halfway line on. And I usually do that by measuring 15 centimetres from the bottom in 2 places and popping a line between it. I'm going to lift this up a little. Okay. Here we are. So I've got too much paper here. I'll use pen for this stage just so it's clear. So 15 centimetres up the page in 2 places. And pop in our starting horizontal. Nice and pale, nice and light if you're doing this with pencil. And can I ask that if you want me to repeat anything or you want me to slow down, just pop it in the chat. Just say I need a couple of minutes or stop a sec or whatever it is. And I'm quite good at keeping an eye on the chat as we go. Then we want to find our centre, which is approximately 10.5 in. And then I think we'll open our compasses to, let's do 4 centimetres. You could just about fit on 5, but let's do 4 so we've got a nice gap around the outside. So I'm going to pop my pen in. And we'll go for 4 centimetres. There we go. And place that first circle. And in a lot of geometric, I've got Oliver in the waiting room. In a lot of geometric art traditions, the circle's quite symbolic. In Islamic geometry, for example, it's thought of as symbolic of wholeness and unity. Pythagoras said it's that from which all else emerges, and it is usually the starting point, certainly for all Islamic geometric patterns, Gothic geometry, rose window geometry, those sorts of things. So our starting circle, where it all begins, and then placing our compass point either side at that first intersection. And stress with children that this is the important bit. This is the bit you need to take care over, popping your compass point exactly where it needs to go. And also, I think, demonstrating under a visualizer how you use your compass, and that this bit at the top is really important. This is where you twist it from. They can, when they're starting out, of course, twist the paper, but it's good to get them to the point where they can confidently twist their own compasses. And students are always completely riveted if you do any geometry under the visualizer. Oh, we got someone else. Okay, if you've just joined us, you've missed the spiel at the beginning, but the video will be shared. And we've just started to construct what's often called the seed of life, or the 7-circle grid. I think you'll be able to follow where we are. And then placing our compass in the next intersection, carefully as possible. And always doing a little check. Does it cross that centre point and that intersection there before you commit? Working our way round. You're probably all there already. And it's always a test. That final circle, or the penultimate circle actually, did you get a little gap or not? If you did get a little gap, just plonk your compass point somewhere in the middle of it. Okay, so this is the 7-circle grid. It's called the Seed of Life, but that's not its historical name. A chap called something Melchizedek wrote a book on sacred geometry in about 1999, so relatively recently. And he gave names to some of these patterns which have stuck. So you will often see this referred to as the Seed of Life. And if you extend it, so if you use this new set of 6 intersections to draw a new set of circles of the same radius, you get the flower of life, and that can be continued indefinitely. And there are all sorts of wonderful patterns hiding in the flower of life. 2 Alhambra patterns, for example, really elegant ones, are just constructed from the arcs, from the circular arcs in the flower of life. So what can you do with your seed of life? So just drawing it on its own, I think, is a nice starter activity to get students used to swinging their compasses again. Get them into the groove. And there are ways, you know, they can take them away and decorate them for homework. So there are ways that they can work with them. They can set them in an outer circle, and they can add some diameters through the pattern to give them more, if you like. This, I always think this reminds me of a rose window or something, to give them more shapes to play with. And they can sort of do some doodling. This isn't one of mine, this is one I found online, and I don't know the artist, but you can see the seed of life at the centre here, and all these reflected and rotated patterns that have been used to embellish it. So this is always a nice task you can set for homework with their seeds of life. This is one I did, and in this one you can see, actually this is the beginnings of the flower of life, and you can see how I've, you know, employed symmetry, rotational and reflective symmetry to sort of embellish the pattern. And this is all mathematical thinking that takes place when your students do things like this. It's not just busy work. It's important. They're becoming, I think it's their visuospatial skills and their understanding of symmetry and things like that are all practiced without them realizing when they do things like this. So that's the seed of life. Am I going to show you these yet? No. Oh, no, not yet. We're now going to, you might want to do a new one actually. Let's construct a double seed of life. What's the time? Yes, we've got yonks of time. Let's construct another seed of life and then turn our new one into a double seed of life. And I'll show you a lovely classroom activity you can do with a double seed of life. So starting again on a fresh bit of paper. I've lost all my paper. What brand of compass do you have? Yes, I always recommend this one or the Stateler Mars. So this is the Jacquard giant bow compass. Let me pop it in. You can find it on Amazon. Jacquard giant bow compass, and this has got with pen attachment and lengthening bar if you ever need to do any very large circles. Length, there we are. So that's what this one is, and I'm really happy with this. It is just starting to get a little bit loose here, and occasionally I draw a very wobbly circle, so I just have to, I just haven't got a small enough screwdriver, so I've got to get one to tighten it up. Stateler Mars is also good. Pen attachments are great. If you want to go on and do geometric art of your own, then you can pop sort of metallic pens in, coloured pencils, coloured pens. You can outline patterns and so on. So really useful, and useful for demonstrating under a visualizer as well, because you can put a pen in instead of a pencil. They come actually, let me show you. They come with a little lead like that, and then that would go in there. Okay, right. Where were we? So we're going to draw a seed of life again. You're probably already there. I'm going to measure up my 15 centimetres. And I might do this in pencil actually. Where are my pencils? A little tip, if you ever need to draw lines that you prefer not to be there, they're your sort of starting lines, then you can, if you draw in 2B, or a B or a 2B, although they're darker, they're actually easier to erase. Harder pencils, are paler but more difficult to erase. Someone's got there, can I just ask you all to check that you're muted, because I think someone's unmuted themselves. Okay, right, there's my centre, 10.5, and I need to catch all of you up, I'm sure, so I'm going to draw my seed of life. Same size radius. Okay, some Christmas crackers. Great tip, thank you, Sarah. Yes, I think I've had sets of those in the past. I think there's a little red one, a blue one, and a yellow one, or something, or a green one and a yellow one. Okay, so actually, I'm thinking I shouldn't have done my line in pencil, but it doesn't matter. Okay, so we should have your seed of life, and now we're going to put another seed of life on top, but we are going to rotate it, I think 30 degrees. It's a bit early in the morning. So how we're going to do that is we're going to essentially bisect. This shape here is called the Vesica Pisces, the fish's bladder. It has a lot of symbolism, especially in Christian art. Christ is often depicted in a Vesica Pisces. And we're going to bisect our Vesica Pisces right down the middle, because what we're after is the point on the circumference of our first circle that's halfway between these 2 points here. And we're going to use that as the centre for a new set of circles, and we'll follow them, we'll chase them around the circumference as we did previously. Now, for the activity I'm going to show you, it's quite nice to put the diameters in, but I'll leave that up to you. You may just want to, if you just want the circles, you may just want to make a tiny mark, because you only need the first center. So you may want to make a tiny mark there. You can't see mine very well, which is your first center. And then, of course, the circles themselves generate the next centers. I'm going to put the full line in. I'm going to erase that. I'm going to put the diagonal in. Is it a diagonal? It's the wrong word, really. And I'm just going to go from the edge of my pattern, keep it a bit neater. And then I'm going to use that point there for my next set of circles. And there we go. And this is where you need to keep your eye on the ball. I need to know where that circle just crossed my my inner circle, and it was there because that's where I'm moving my compass point to. Where did that one go? There. Okay. And it's always difficult to know if you've done that last one or not, but I can check the petals. You can always remind children, check the petals of your flower. Is every petal complete? And I can see quite clearly I need one more circle there with its center here. Okay. And I think this pattern is gorgeous. It's got a lovely sort of bubbliness around the outside, and it's just really elegant. And it's those proportions that are naturally inherent in circle geometry. Good old pi and its irrationalness. I think that's what's making this very pretty. So how can we use it with children? Well, actually, I'll come to that in a sec. I'll show you what students can do to just ideas that students can use to just decorate it. Imagine I didn't have that straight line in. We'll be putting some lines in a bit. So what have I got to show you? So I'm going to show you some of my own bits and bobs. I might lift this up a bit. I think it was for June. I can't remember. We did so many hashtag challenges, Jacqueline and I. It might have been Geometric July. It might have been, oh, there's a June bug challenge one in here as well. I'm going to show you first of all. Yes. So this is where are the others? Oh no, I think I've shown you that one already. Right, I need my coffee cup out of the way. Let's move this under here, bring that down a bit. So you can't see it very clearly, but this is a double seed of life underlying. Pull this over a bit. The underlying grid for this was a June bug challenge mandala I drew. And you can see that I repeated a third of the pattern. So from here to here. Oh, difficult to work out, from edge to edge, I think. Oh, I can't, too early in the morning. But anyway, what was quite nice to do was to use the circular arcs to make a feature of the circular arcs in the pattern. You can see the double seed of life underneath, and then to play with reflection and rotation symmetry as well. So you can challenge students to come up with a design. You could give them a theme, leave it to themselves, that sort of thing. And this one is also a very large double seed of life underlying this one. And for this mandala, I experimented with the golden ratio. So this is my opportunity to show off this whizzy tool. Right, this is, I didn't know this was a thing, but these are eyebrow golden proportion rulers available quite cheaply on Amazon, because apparently it's a thing to have your eyebrows plucked according to the golden ratio at the moment. which is great for us maths teachers because golden ratio calipers are really pricey, but you can get yourselves a nice set on the cheap. And you can do your eyebrows as well. I don't know how it works, but hey. So these, as you will probably be aware, let me put them over a white section of paper. If this length is 1, then this length is phi, and the whole length is 1 plus phi. If this length is 1, then this length is phi. So each division is phi times the smaller division. And I did my underlying double seed of life, a really big one. It came sort of out here because I wanted 12 divisions, and it generates 12 quite nicely. And then I thought, I want to put some concentric circles in. What would it be like if I used the golden ratio? So you can see that, for example, this way round, if I go from the center to this point here, you can see quite clearly that this and this circle and this circle are golden ratio proportioned. And then I made it a bit smaller. So if I bring that down to there, you can see there was an underlying circle here as well. And I went smaller and smaller. There's another one. You probably can't see it very well, but there's a circle there and that circle there are all golden ratio proportioned. So that was quite nice to just play with. And the underlying grid is that double seed of life. So it's nice for doing mandala making. And you have to think, of course, about reflection, rotation, symmetry, and so on and so forth. So that's that one. If you are very intrepid, you might want to turn your double seed of life into a torus. So you simply just continue the procedure of bisecting the divisions on your central circle. So, for example, I would put my ruler, if I wanted to bisect this little section here, pop your ruler through, like that, find that point, make a mark right there, and that becomes the centre of another set of 6 circles. And you continue in that way. And I think this one I did a little differently, actually, but we did one on my geometric art course. I think it was 48 circles, was it? Lot of circles, and you can set that as a challenge for your children as well, because they will become super confident with their compasses after drawing a torus. So that's something else you can do as an extension challenge. I think I'm going to leave it there for the mo, and going to come back to, are there any questions? No. I'm going to come back to our double seed of life, and I'm going to now put all the divisions in, and this division here, I'm going to extend this one out to the edge of my pattern and down, and then I'm going to put the remaining divisions in. So if you don't want to ruin your beautiful double seeds of life, although it's not ruining it, it's just adding interest, you can put yours in as well. I can sense a little bit of inaccuracy here. But I'll show you how this can be used as a nice factors activity, factors challenge, once I've got my divisions in. And again, lots of practice of these micro hand-eye coordination movements that students, there's a lot of work that goes on in lining up a ruler accurately. You always have to check the other end, because every time you move one end, the other end moves. And students don't get good at it without doing it. Nearly there. I'm just going to remind you to check your mics again, because I can hear someone clicking away in the background. Here we are. Okay, actually it's pretty funky with the lines in. Make that straighter. Okay, so you might still be finishing off your lines, that's fine. So this is a great grid, you've got 24 divisions. How can you use this as a mathematical, both mathematical and geometrical task, a numerical and geometrical task? Well, you can ask students to create a design so that they pick out the factors of 24 in the design. So for example, let's list them first. So, for example, and they can tick them off as they do them. So if I wanted to pick out the number 1 in my design, I could just enhance one of the circles. Perhaps I'll do that quickly now. I might enhance my central circle in some way so that I've enhanced the concept of oneness in my design. And then, so that's 1 done. And then for 2, well, I might embellish my design in some way along the central axis. For example, I might add a sort of embellishment at the top here and one at the bottom, so that my design now sort of has a sense of 2-ness. And then 3, well, it's starting to get challenging now. But because 3 is a factor of 12 and I have 12 petals, I could do something unusual in my sets, in 3 of my petals. Where are we? Is it this one? For example, have I done that right? 1, 2, yeah, 2, 3, 4. And find some way of enhancing 3-ness. I could put something in here as well. Okay, and then I've got to tick off 4. And so we can see we have these points here, which I could use. They form a square. And I think the idea is that you've got to keep symmetrical because I think students used to understand that you can't do something symmetrical with 5, for example, because 5's not a factor of 24. And so the idea of how factors fit in to their multiples is kind of coming through in the geometry and in the decoration of the pattern. So 4, I might, I don't know, do something with these points of these points that make up my square, and so on and so forth. So I think you get the picture, and it's a lovely challenge, I think, hopefully you do too. So this grid is ripe for A, compass practice, and B, getting students to think about symmetry and to think about factors. Okay, so that's that little task for you. Now I think it's time to get Christmassy because Halloween's over, so there's no excuses now. We can start thinking about Christmas. I don't know about you guys, but oh, I need to decorate my house with prettiness. So so I think what I'll do now is talk you through my presentation. The presentation I'm going to show you is my digitally remastered one. Let me change camera, which I might well use in a future Artful Maths book. But there is a free version which is nearly identical with all the ideas on. There's a free version on the website. If you scroll down to the bottom of the resources, mathematical art lessons page, I've just prettied it up a bit. So the version you see today is the prettied one, but there is, well, it's also pretty. There's another pretty one, which is a bit less pretty on the website. So I'm going to show you that now, and this is how I would introduce this lesson on snowflakes. Just double check, does anyone want me to slow down or stop a moment, or has anyone got a question at this stage that they'd like to pop into the chat? Because I think we're doing quite nicely for time. We may finish a little early. Okay, good. Right, I'm going to share screen again. Go back to my PowerPoint. Okay, so we've got here, and I wouldn't normally show this at this stage. I would show how to construct the underlying grid a little bit later on. But I would start by saying, we're going to draw some snowflakes today. We're going to construct some snowflakes mathematically today. And then I would ask them to think about what all snowflakes have in common. And there's some lovely macro photographs online by a chap called Alexei Kliatov. And they're available on a Creative Commons license, so you can use them in the classroom. And I would show them some pictures of close-ups of snowflakes. And that tubular one's great. And draw from them, you know, what do they all have in common? You can emphasize the fact that every single snowflake is actually unique, but they have this thing in common. And of course, it's the idea of sixness. They have 6 arms. And even this little chap here with this this prism body has got 6 little bits either end. So they all have this this sixness. And you can then sort of say, well, then, so what shape are they based on then? And of course, they're based on the regular hexagon. And then you can ask a little bit about the symmetry. So how many lines of symmetry do they have? And I think that the first 3 are obvious, down the arms. But there are, of course, another 3 between the arms. So talking about the idea that you could fold the snowflake over directly on top of itself along any of these fold lines. And then last of all, talking about the order of rotational symmetry. And I think that can sometimes be a difficult concept for students to grasp. And I often explain it as, you know, how many times can I turn my shape round and fit it back on top of itself within a full turn? And so, so there we go, 1, 2, oh, I've gone too fast. Hang on, didn't realise I put my animation in. 1, 2, 3, and so on. And 6. So snowflake symmetry is order 6. And then you can explain that a really clever thing about circles is that they create patterns with 6-fold symmetry just naturally. And oh, this was don't worry about this, this was from another lesson. And that's when you can then show them the underlying grid, which I've been through with you, so I'll just whiz through now. And I would demonstrate it first, and then ask them, you know, to put their pens and pencils and compasses down while you demonstrate it. This is what we're going to do. You could ask about where there are hidden hexagons. So of course there's the central one, but you can put another hexagon in using some of the outer intersections as well. So ask them to sort of find the hexagons hiding in the grid. And then we'll come back to this now. So I think what we'll do is we'll create our underlying grid, and then which is what you do with the students, create your underlying grid next together. Then once everyone's got that in with their diagonals in, then come back and show them how they can design their snowflake. So let's on-screen share. Let's just draw another. We can do it. I'll show you. This one was done. Oh, hang on, wrong camera. This one I did the other day as a demonstration for something. And this is done with a 5 centimetre radius. But if you want to do a smaller one, you can stick with your 4 centimetre radius. Oh, good, good. Okay, so I need a new bit of paper. If you're someone that wants to decorate the snowflake, if you're someone who's kitted up with all the art stuff, and you've got some watercolour paper or something like that, you can construct this straight onto your watercolour paper. But A4 paper's fine. And I realised I've forgotten to switch video. But you all know what you're doing at this stage, so so off you go. I shall just. We do need. Actually, no. I'm going to do my first horizontal in pencil, We will need our diagonals in at some point, but pencil's best for those because we don't want the underlying grid to show too much. I think it's always quite nice to see the skeleton behind the pattern. I'm going to do a smaller one this time, I think. Yes, I'm going to stick with my 4 centimetre radius. If only out sheer laziness. Let's check it's still 4. But 5 is your max on A4. I'm doing mine in pen, of course, just so you can see it. This will be the underlying grid, so not the pattern itself. So pencil. And we don't need the double seed of life, we just need the seed of life, the 7 circle grid. Okay. And I'll pause a sec and give you a chance to get there. And yes, let's put the diagonals on as well. We need 12. No, we need the 6 lines of symmetry. Yeah, 6 lines of symmetry in. So we need the 3, if you like, main ones, and then the 3 in-betweeny ones. Am I going to come out of my circle? Just thinking about what I did. I think it's quite nice actually to add the outer circle in, and then we can extend our, oh, taking my pen out. We can extend our circle out. You don't need to do this. I'll just demonstrate it as an option. So I'm going to extend my compass to the edge of the outer circles and pop in an outer circle. And this will contain my snowflake. Then, when I put my diagonals in, I'm going to extend them out to this circle. Diagonals, they're now diameters, aren't they? So these 3 first through the outer intersections. Dividing our circle into 6. You can ask about how many degrees each sector is, that sort of thing. And then the ones that go through the flower petals, the tips of the inner flower petals, to give you your last 3. Okay. Let me know if you would like me to pause for a couple of minutes. I'm just having a quick swig of cold coffee, teacher's favourite drink. Okay, I'm going to show you a pattern that I've done with this technique, but not with 6-fold symmetry, with 4-fold. Here we are. So this is, take that off. So you can see quite clearly the squariness of this design. So I constructed, I can't actually see it underneath the pattern. I may have constructed it on a different piece of paper, but I divided a circle into 8 and popped these divisions on here. And then did the technique I'm about to show you. So essentially you design a single sector of your design, and then you rotate that round. well, you reflect and rotate around to create your design. So there's all sorts of fancy stuff you can do. It doesn't need to be Christmas themed. This is looking a little bit octopusy or something. So students have great imaginations. Let them take their patterns. When I last did the snowflakes lesson, I had some aliens, alien snowflakes, and cats, and all sorts of things. Yeah, they have great imaginations. Okay, so I'm going to go back to my. Oh yes, you could absolutely. I had not thought of that. The 12-foldness, super useful. I'm going to pop back to my screen to demonstrate then how we're going to design our snowflake. And then I'll show you a nifty little trick. You just need an A6 sheet. So I'll quickly cut that up now. This was A5. You can use a bigger sheet if you wish, but this is all you need. So we're going to use an A6 sheet, but we're going to fold that in half, and I'll show you a nifty little trick for getting a whole blade of your snowflake, if you like, a whole arm of the snowflake rather than just half an arm, but we just design half an arm. Let me show you that now. This one. Okay, so designing your snowflake. So students now have this grid, and we only design half a point or half an arm of a snowflake. So you can show students this animation. So there's one I've done. And I think the nice thing to show is that you can start off with a really simple initial, what are we, 12th. But it's the reflecting and rotating that gives your snowflake its complexity and its snowflakiness. So then we're going to say, then we're going to use tracing paper to reflect it across the line. And sorry, I should have done that a bit slower. And then they can see the snowflake emerge from just that one section. And then if they're doing them on white paper, if they're nimble with their scissors, or give them practice in getting nimble with their scissors, they can cut them out, and you can mount them on coloured backgrounds, that sort of thing. So that's the general principle, which I would show them first, and then perhaps demo under the visualizer step by step next, so they have an idea of what they're aiming for. Is that the last slide? Yes, I'll come back to that at the end. Stop share. Okay, so right, I'm going to show you this one as well, actually. This one that I made earlier, or the other day. This is quite nice to see. This was my initial design. So that initial design created this snowflake. And it might be quite nice to allow students on their phones to Google snowflakes. If they want to make a snowflakey snowflake, then they could Google some images of snowflakes to just get an idea about how to structure theirs. So you can see here, I did a main blade, and then I did a sort of mini sub blade or sub arm, which gave a little bit of additional complexity. So they can do that if they wish, and they can get their inspiration from real life snowflakes, or not, aliens and so on and so forth if they wish. So a little trick which students don't need to do, but they can do, and this is a trick that I've seen employed for doing biomorphic patterns, is to fold your sheet of tracing paper in half first. I'm going to pull this down a bit and actually maybe turn it around a bit more. That's better. Okay. So, and then what you're going to do is you're going to put your folded edge along your centre, more or less perfectly, and ensure that your tracing paper sits under your centre, because with a pencil, I'm going to use 2B, but HB suffices. I'm going to mark that centre because I want everything to end there. And then I know that that's my central line of symmetry. I'm now going to dot on that second line of symmetry that I need. And I'm now going to design my snowflake on my tracing paper. Students could design it on the grid and then trace it and then rotate it. But I'm going to design it directly on the tracing paper, so I'll turn that over. And I know it needs to fit into this section here. And then you just kind of got to let go a bit and do something or other. I'm going to have my central blade at the top. So this is going to be a longer arm than this one. And so I might go spiky today. Starry. Literally just making it up as you go along. And I'm at the spiky bit there. Okay. I might put a couple of circles in mine, and I might want a central bit. I'm going to put a little arch in there. Maybe a little inner bit there. Okay. Students could even do little Christmas tree ones, couldn't they? Seeing the star at the top there. Anything goes, basically. Now, the next step, I'll just give people a moment, actually. Give people a moment to design their 12th. Tracing paper looks like a reindeer. You might have to explain that a bit more. I can see a face in mine, actually. The nose at the vertex. Ah, yes, either that way up or that way up. Yes. Okay. I'm assuming we've all got there. You can pop in the chat if you haven't. Then on a different piece of paper than your beautiful 7-circle grid, which you're preserving, we're now going to turn that piece of tracing paper over and trace the design onto the other side through the tracing paper, because then we're kind of killing 2 birds with 1 stone. We can get a double whammy out of our piece of tracing paper. Because actually I think the transferring the pattern from the tracing paper can be a little bit tricky. So the less times we have to do it, the better. So I've copied the design onto the other side, and I also need to pop my axis of symmetry in, because this will then help me with lining everything up. And then you can open it up. And a rookie error at this stage is to have copied it onto the wrong side of the tracing paper. So double check that your graphite's on one side. And it's quite good to encourage kids to make nice thick lines. I might thicken mine up a bit, because of course we're transferring the graphite. And so the more graphite there is, the better. I'll just go over mine. Looking very googly-eyed. There we go. Could you use card as a template? Do you mean to, Grazia, do you mean cut it and then cut it out? That would be an idea. You could draw it on a piece of card, cut it out, and then just draw around it. Yes, nice idea. Okay. Okay, and then once you have your 6th of your snowflake, with 1 central arm and 2 little side arms, if you've gone in for the side arm look, then it's students can transfer in 2 ways. And I don't know about you, but when I was at school, got to line it up in where we need it. When I was at school, I transferred from tracing paper by scribbling on the back with another pencil. to transfer the graphite. But that's really messy, and it means you can't reuse your tracing paper because it gets yes, greaseproof paper is good as well. So there are other ways of doing it. So one way is to actually use your pencil. Where's the better pen? Here one. You can redraw the pattern on top with a pencil. So I'll just demonstrate that. I'm sure you're all aware of this technique. And then students would have to do that 6 times. And that gives you a pretty good transfer. The other thing you can do, and it's handy to have a little bit of masking tape as well, the other thing you can do is use a burnisher. And this is where our spoons come in. So I usually use the edge of my spoon. You can use the base, and you can, at a push, if you have a pen or a pencil with a nice rounded end that won't scratch the paper, you can actually use the rounded end of a pen or a pencil in the same way. And essentially you use it instead of, well, you use it to burnish the back, and you can see that transfers the graphite quite nicely. So spoons are good. Just check your spoon doesn't have a rough edge. And then I just basically scribble it over the top to transfer my pattern. Okay, and you only need enough of the transfer down that you can see enough to then trace over it with a pen, or so on and so forth. And then we're off, aren't we? We're rotating. We've done our reflection, and now we're rotating our blade around. Very much looking forward to seeing what you lot are coming up with. I've got this the right way round. Yes. Or have I? Yes. Okay. Well, one thing I didn't mention, it's quite important to sort of stretch out your tracing paper with your fingers. Otherwise it can sort of crumple up underneath the spoon. So stretch out and then press down quite firmly before burnishing. And if students haven't got enough graphite being transferred, they may have to sort of re-ink, re-pencil the other side of the tracing paper to just lay down a bit more graphite. Okay. And I think it's always a rather magical moment when you see what you've actually produced. See your snowflake come to life. Okay, mine's down. I might, just for the purposes of today's session, outline it in a thick. I go for Sharpie. I'm going to outline mine in blue Sharpie. We've got a bit of time for these frivolous extras. And to be honest with you, we've kind of come to the end. There's a couple of things I want to direct you to. I might show you a few Christmassy activities on the blog. And then there's time for some sort of questions in the chat, or and we can of course show off our snowflakes, the most important part of the session. Quite pleased with this strange one. Yes, that's a good point. Using tracing paper is a requirement really for our students, and we don't want them to only have used it a couple of times in their maths career before they're required to use it in an exam situation. I think one of the main reasons why geometry and measures questions are left unattempted is just student confidence. And the more familiarity they have with both constructing geometry and then playing with it and exploring it and finding the relationships in it more intuitively, it can only improve their outcomes. And also we've got the designers, the architects, the graphic designers, the product designers of the future come through our maths classrooms. And these sorts of activities might well be the thing that spark off a lifetime interest for some of our students who have both got an acute sense of the aesthetic and also enjoy their mathematics, or don't know they enjoy their mathematics yet. You know, these sorts of activities can really spark off some students' interest. I'm nearly there with mine. Oh, I forgot my middly bit. And I think the other nice thing about this type of design and all sort of mandala designs is that what you produce in one section can often look you can often be disappointed by what you produce in one section of your mandala. But as soon as you've then rotated and reflected it around the full design, it then just comes together aesthetically. Because I think as humans, symmetry, we're drawn to symmetry. We find symmetry pleasing. So even the most basic of designs, once transferred around the whole design, suddenly has charm and becomes pleasing to the eye. So you can't really go wrong. I don't know, my little inner bits. Okay. So that's my snowflake for today. Very pleased with my work. I am going to just come back to sharing my screen, and I might actually go to the Artful Maths blog as well and show you a few things. Where are we? This one. So yes, there's a free version of this presentation, different colour scheme, but essentially all the same slides at my website in the Mathematical Art Lessons page. You just have to scroll down towards the bottom, and that's in the resources section. And then I did this lesson yesterday for Maths Week, and we also used the Seed of Life, the 7-circle grid, to construct hexagrams, 6-pointed stars, to use on. In fact, I might show you my. I'll show you in a sec. So we used the same grid, first of all, to construct our stars, and then we went on and constructed our snowflakes. But if you'd like to construct other sorts of Christmas cards, then there's a blog post on how to construct a pentagram Christmas card and how to decorate it. So that's in the blog. And I might show you a few more other Christmassy things in the blog now, and then we can have a little bit of time for questions. So let me just get up my website. Oh yes, these are, where are we? I'll share my screen in a sec. So these are the, we made, or I showed how to make little hexagram Christmas decorations. I made a little hexagram garland, and you can also use, design some hexagram Christmas cards. So that's something else you can do with the same grid, really rich grid. And I'm going to share my screen again and go to my website and show you a few more bits. Where are we? Here we are. Okay, hopefully you can all see this. If you go to the blog, you can, now I can see you down, all of you down the side. I might move you over here. You can, if you scroll down, you can search by category. So if I click on Christmas, if I've remembered to tag the blog post, it'll come up. Here we go. So there's construct a Christmas card, that's the pentagrams one. And spirograph Christmas cards, who doesn't love a spirograph? There's origami snowflakes. These are probably for older learners or more experienced origamists, perhaps in an origami club or something. So there's links to instructions for origami snowflakes there. And what else have we got? Origami Christmas decorations with an outer space theme. Don't know what possessed me, but there we are. Actually, that wasn't my idea, that was my student's idea. This is, I did a STEM club, 6 sessions or 5 sessions for the STEM club. And we looked at fractals and folding Christmas fractals. So we started with Liz Neenan's activity, and then we looked at cock snowflakes, and we used Liz Neenan's paper folding activity to create some cock snowflakes. We had to work out the proportions for the little arms, and they had to cut their A-sized paper down into the correct size to create the smaller triangles and so on. And then, of course, there's the Matt Parker's fractal Christmas tree. We made one of those as well. That's a fantastic activity, a really good teamwork activity. And then there's this, I can't remember. Oh, Emma Morgan has done a nice video for folding a fractal Christmas card as well, which is really nice. So there's some ideas, there they are. So there's some ideas for fractals in Christmas. And then there's more conventional, less alien themed origami Christmas decorations as well. Lots of links to diagrams and videos. So that's, if you're interested in some other Christmas themed activities, check out the blog post. And I'll show you where the lesson is. It's in Mathematical Art Lessons on the resources page. And you scroll down a bit. And there we go. So there's the presentation. And Mr. P.R. Collins did a blog post about it. I'm not sure if his blog post is still active actually, but these are the ones his class made. There we go. Right, I'm going to stop sharing now, and hopefully we won't. I'll change my video. Hopefully we won't overload the Zoom server. If we all if you'd like to sort of unmute yourselves, if you have questions, actually let's unmute video, and otherwise it will get very noisy. So we can unmute our videos, and if you have questions, you can pop them in the chat. And I'm going to put into gallery view. If anyone wants to show off their snowflake, is that the way? Oh, lovely, Dr. Austin. That's gorgeous. Oh, they're so good. Yours has got like the scream, Sarah, going on. Aren't they fab? Oh, Christmas trees and stars, Lindsay, that's gorgeous. Really lovely. Oh, how nice. if anyone has, oh, let's have a look. Are there a range of activities that can be developed for Key Stage 2 children? I always say that most of these activities are useful from about age 9 up. So with a little bit of support, essentially. So for some of my lessons, there are starting, rather than students constructing their square, because they might not be at the stage where they're ready to use compasses, there are some starting templates with the corners of the square already marked off, so they just draw in their square. So there are all sorts of support materials that can be used to allow younger students to access the same ideas and the same activities. But my focus is now sixth form. It's always been secondary and it's now sixth form, so I have to confess I've not done that much thinking about younger children and how they would access those ideas. People on Twitter that are good to follow, Simon Gregg on Twitter is really great to follow. He does most wonderful activities at a primary school in France. I think he's based in France. Yeah, really loads of lovely inspiring stuff. Anyone else got any questions? Actually, let me look up Simon on Twitter and I'll give you his handle. It's Simon_Gregg, and it's Greg with 2 G's at the end. So Greg with 3 G's in total. In fact, I'll pop it on here. He is at, oh, there's someone in the waiting room, admit. Everyone. He is at Simon_Gregg. He's at the International School of Toulouse and just does incredible things with his students. Really inspiring. I'm getting sidetracked now. Okay. Oh, and the other thing I was going to do was I'm going to type in. Was I going to put the list of the artists in? I wasn't I? So the artists in order. Oh, brilliant. Those macro photos are so stunning. So the artists in order, I'll type them in, are Escher, and then Hamid, Naderi, Yegane. I'm not 100% sure of the pronunciation. Hopefully I'm not doing him a disservice. He's on Twitter. Tom Bedard was the one that looked like laser cut wood, but was actually just. Hamid is the trigonometric chap. Tom Bedard is the one who'd done one that fractals that looked like they were carved into wood, but they were actually computer generated. Then there's George W. Hart, Vi's dad. And then there's Bathsheba Grossman, was the 3D printed one. Bathsheba, I'm foregoing capitals, Grossman. And then Regulo Bitsy is the one that it can be really inspiring for students. I do Zoom lessons with a little 9-year-old lad in Australia at the moment, and he's really into his impossible objects. And we spend the whole time copying Regulo Bitsy's work at the moment. So Regulo Bitsy. There you go. Okay. Okay, if no one else has got any more questions and you're all happily colouring in your snowflakes, I might hand back to Japleen now. And yeah, that's me done. I do hope you enjoyed it. Oh, Alexi. Oh yes, hang on, the snowflake chap. Hold on. Alexei Kliatov is the snowflake chap. Okay, wow. Japleen, all yours.
Thank you, Clarissa. That was amazing, absolutely amazing. I'm only half done mine. I will put it on Twitter when I've finished. Oh, that was absolutely amazing. Thank you so much for giving up your morning, and thank you for everybody for joining us. And the next session, I'm hoping to get Jonathan Hall from Study Maths to show us his website, but it'll probably be in January, February time. So everybody, hope you can enjoy this with your classes over the Christmas break, well, during the next half term, and stay safe, really.
Thank you, Jacqueline. It was a pleasure. It was a pleasure.
Thank you so much, Clarissa. Honestly, I really enjoyed your sessions.
Good, good. I think we all need a little bit of this sort of downtime.
Yes, definitely.
Okay then, peeps, I'm going to say goodbye.
Thank you very much.
Pleasure,
Bye.
Jacqueline.
Bye-bye.